Tutorial 14. Encapsulation Introduction. This tutorial will cover the concept of encapsulation within Max. Encapsulation allows us to place sections of our patcher within their own subpatch using the patcher object. This lets us hide parts of patcher logic that we no longer need to see, in order to make our projects easier to read and more concise. We will examine the creation of a patcher that contains objects, as well as using some editing tools to encapsulate parts of a patcher that no longer need to be seen. Properly encapsulating your Max logic is important for keeping your patch files clean, easy to read, and maintainable. Encapsulated logic can be easily edited, and can also be saved as separate files that can be reused in other patches. Basic encapsulation. At the top left of the tutorial, there are two small patches that do the same thing. They both add 5 to the incoming number. The patch on the left does it with a plus object, while the patch on the right uses a patcher object. The patcher object is literally another patch embedded in the current patch. To see the contents of a patcher object, you can double-click on it to open the encapsulated patcher objects window. If we double-click on the patcher add 5 object, a small patcher window shows the contents. It is a simple subpatch, with only 3 objects. The object in the middle is obvious. It is the plus object that performs the addition. The objects above and below the plus object are inlet and outlet objects, respectively. An inlet object causes the enclosing patcher object to have an inlet, while an outlet object causes the enclosing patcher to have an outlet. In this way, we can make patcher objects that act very much like built-in Max objects. Multiple inlet and outlet objects will create corresponding inlets and outlets on the enclosing patcher object, arrayed spatially in relation to how they are in the subpatch. When working with inlet and outlet objects, it is useful to add assistance to them. In this way, the enclosing patcher can display helpful information about the type of message that is expected by the inlet, or produced by the outlet. If you select an inlet or outlet, and then open the Objects Inspector, you will see that there is a comment field available. Any text that you enter in this field will show up as assistance in the patcher object during patch editing. Performing encapsulation. Creating subpatchers sometimes needs to happen after the logic is in place. Perhaps your patcher has expanded beyond where you originally thought it would go, or you've added logic that wasn't planned, and things are starting to get messy. In these cases, it would be useful to be able to select a group of objects and quickly turn them into a single encapsulated patcher. This can be done using the Encapsulate menu item. Our example patch has an interesting drawing algorithm, where you move a puck around a rectangular area, and small circles are drawn in the area randomly near the equivalent position in the LCD at the bottom of the patch. If you need to clear the LCD, you can hit the space bar. The logic is rather messy, and it doesn't really help us to see it spread around the screen. We are going to select a majority of the logic and encapsulate it into a subpatch. There are 2 comment boxes that we will use to select our encapsulated logic. Unlock the patcher, then select all of the objects between and to the right of the comment boxes. 15 objects will be selected. Select Encapsulate from the Edit menu, and you will see that all of this logic is folded into a single unnamed patcher. If you lock the patch and double-click the patcher object, it will open the subpatch and show all of the objects again, tied to the outside world using 4 inlet objects and 1 outlet object. If, for some reason, we needed to reverse this process later, the encapsulate command under the Edit menu will unravel the subpatch back into our main patcher, reconnecting everything correctly as it was originally. It is often useful to name our patcher objects. While this adds no particular value to the patcher, it will help you understand the logic that is encapsulated into the object. To name it, just click inside the object, and add a first argument that is the name you'd like to use. Something like draw logic would be perfectly useful for this example. Creating our own subpatcher. When you know ahead of time that you want to work within a subpatch, it is easy to create a patcher object and work within its editing window. At the lower left is a pair of number boxes connected by nothing. We will make a subpatch here and use it to convert one value into another. Create a new, blank object in between the number boxes by parking the mouse there and typing N. In the new object box, type pMyCalc. This will create a new patcher named mycalc. A new window will appear for editing our new subpatch. Start with an inlet and outlet. Note that adding these to the patcher added an inlet and an outlet to the patcher object in our main window. Next, connect the inlet directly to the outlet, thereby making a through object that does nothing except pass incoming message to the outlet. Let's test this encapsulation in the main patcher window. Now that our MyCalc patcher object has an inlet and outlet, we can connect it to the number boxes. Connect the top number box to the patcher inlet. Connect the patcher outlet to the bottom number box. Lock the patch, and change the top number box. We should see the bottom number box change to match. This shouldn't be a surprise, since our patcher object encapsulates a straight line between the two boxes. Let's go back to the patcher editing window and add some logic. If the window has closed, double-click the patcher object to open it up again and unlock it. Start by selecting and deleting the patch cord connecting the inlet and outlet. Now let's add some math. Create two new objects, a +50 object and a 7 object. Now, connect the inlet to the plus object, the plus to the object, and the output of the object to the outlet. We've changed our MyCalc encapsulation from meaningless subpatch into an 7 patcher. The nice thing about doing this within an encapsulation is that we don't have to change anything in the top-level patcher. All of the connections remain as is. Now, at our main patch, changing the top number box will produce the new result without any further changes. Summary: encapsulation of patching logic accomplishes two things. It allows us to work at higher levels without having to interact with all of our objects, and it allows us to change our lower-level logic without having to change anything at the higher-level programming. In working with patcher objects, you can either manually create and populate them, or you can select existing patcher logic and use the Encapsulate menu option to automatically create a subpatch. In either case, you can further explore and change the patcher code without any further changes to the higher-level patch.